We have in-house fabricating capability, pretty decent capability. We do farm some stuff out, plasma cutting, that sort of stuff, machining we farm out, but we do have a good crew of fabricators and capability. So we fabricated a pair of these, just kind of give you an idea of the size. So there's the upper works, the big counterweight. We used shivs out of one of our 2250s that were available. That saved us a little bit there. We looked at taking them out of some of our blocks, but at the end those were the biggest, nicest, easiest to use. Well, then, question, should we or do we need to test load this? Well, regardless, we were going to test load it. That's just kind of our policy to do, but there's, sometimes debate. ASME B30.20 says should test, unless you're modifying and that sort of stuff. OSHA says you shall. So we did test it. We tested it by putting it into, using our gantry system as basically a big test stand. And we used all the components we're going to use on the job, and we were able to, capture the reaction beam underneath the track of the gantry system. Now, this complete gantry system, I've got 11,000 pounds each tower, 20,000 pounds each track. So I've got quite a bit of weight, just dead weight there. And because I'm multiplying, I'm only pulling up one line pull, only pulling 30,000 up on this thing. I'm just multiplying between the upper portion beams and the lower track. So I'm just basically self-reacting. So we're able to test load them in our yard before we took them out there, and also verify that they worked the way we want them to, and indeed they did. So we had to do some more engineering here, make a bunch of submittals as to how this is going to fit. Where do we want the roof opening? All that work had to be, carefully and precisely planned ahead of time so things would flow and work. Again, because boilers are built to suspend, there was a lot of steel structure up there, 11-foot tall steel girders, that sort of stuff. And most of the boiler weight was now gone underneath. So there was no issue with having steel to support off of up there. These are some of the auxiliary pieces that we designed. Again, our CAD system could tell us right where the center of gravities were, so we could design these things balanced to fly in with the crane. So it was designed, so ahead of the fixture, a day ahead of time, we flew in a support beam. This is on each end of the boiler. And then a bracket, a pedestal for that assembly to come in on top of and land. And in the end, are just two bolts to put it in. Trying to maximize use of the crane and the crew the day we're doing the lift, do as much work ahead of time as we can. And again, we're doing all of this work in 3D CAD in the virtual world to make sure things are going to fit, make sure we got the clearances we need, make sure this is going to work right the first time. So there's the where we predicted it would fly through the assembly. You can see we predicted we were going to hit a roof brace. You can see they cut the roof brace out for us. You can see on the girders there. So this would come down through the roof, each crane lifting and flying one in sequentially. It kind of got below the roof line, can move over a little bit. And then there we are, resting on our temporary steel on top of the big boiler steel. And then now it's time for us to lower our block down. So as soon as we land down and touch, now we start letting line out. We're no longer two blocked anymore because we're, the top part is now no longer free floating. It's stationary. So now we can take the block down and pin it into those existing boiler lugs. So one of the challenges you have, we got these big links coming down, and you see we got just extra weight in between them. Well, I've got these two great big hydros with one of them with a big luffing jib, and we had to have 900 pounds of overhaul to pull that line back up and over the crane. The big headache balls you see, the big weight you see on the end of the line to get it up off the crane so it doesn't come back down. Well, because I'm now 7-to-1 with this big pulley block and tackle system, I'm losing line pull 7-to-1. So if I want 900 pounds line pull to get my line up and over, I've got to have that times 7 of dead weight on this block now to get that back over. That's why we just had to just put weight anywhere we could just to get our overhaul now that we're lowering this block down. We Before we got to this stage, Xcel Energy, they did NDT testing on the lugs, make sure the welds were still good after being up in this boiler for almost 50 years, I think the boiler was. And then we also brought them up a piece of tubing that was the same OD as our pin to make sure the bore through those 3 lugs was still aligned, was still going to work. We didn't want to find that out the day of either. So we lowered our block down, and we had about, if I remember right, about a 4.5-inch diameter pin to go through all that. Iron workers did a good job, manhandling, wrestling that in there. You probably can't see it on this picture, but we were very safety conscious. We're safety conscious. We have to be in the trade we're in. It's just the right thing to do. So I'm glad to hear we mentioned safety in here. Glad you guys got a safety committee. But we work with the trades. We do all the hazards evaluation. We have the whole plant bottom cleared out for this. But one of the things we did was we chained that big pin up. We had a chain just in case it got loose. We didn't want that thing banging down 130 feet through the plant. You can see the U-bolts right here in the foreground. So go ahead and play this one. So this is the actual time lapse of the lowering. You can see the 2 big blocks. The 2 big yellow things are blocks. You guys want to play this? Should be a video. There we go. All right, so we had to kind of, we got 2 cranes working in tandem. We had to get those U-bolts to clear. We had to clear the operating floor. We got a little hung up there. Some scaffolding slowed us down a little bit. Some clearance issues. All the way down to the basement of the plant. At that point, they're going to chunk it out in pieces. We go into these projects. We do a lot of engineering. We're confident what we do. We have to be because that's the field. But it's a good feeling, all right? The engineer in charge of that project, you just feel real good when it's all the way down there. Nobody got hurt. Everything went the way you planned. That's the big U-bolts clearing. We had iron workers on top. So we had one of our superintendents calling each crane. We had radio on a common channel, 2 cranes, and then we just slowly let it down. We weren't sure how it was going to behave coming out of there. It was our only concern. There was no issues coming out of there. And that's where it is sitting down in the basement floor when we're all said and done. That's looking up from the basement where we started. Kind of looking up, make you a little dizzy sometimes, but that's the distance that we let that down. They're doing a little bit of work in the basement. They had to cut off some stuff, and then they're going to tie it up to the building so it can roll anywhere. Some other just miscellaneous, nice thing about this project is Xcel asked us to do, we do a lot of this work hard bid, a lot of our stuff, because we're pretty good at what we do. We know what's going to take. And you can make some money on hard bid if you get it done early. Xcel asked us to do this project T&M. We're like, hey, whatever you want to do, which worked out real good because they just kept throwing a variety of rigging projects at us. And this is, just shows you some of the complex situations. This is one of the control modules that's going to go into the plant eventually. And, we had a low headroom situation when it was going to go into the plant with the in-plant overhead crane. So we, devised rigging, and we were able to do a lift outside with the same rigging, make sure it worked, behaved to one. You can see some good wire rope there around the trunnions, variety of synthetics on top, and spreader bars going each way. And again, if we mentioned we use a lot of products. We're in the rigging industry, so things that you guys manufacture, things that you sell, we use a lot of it on a daily basis. It's the combustion turbine on our big, one of our Goldhoffers moving from storage over to the crane. Get a few more minutes. Let's bring up the CT. I think it says Black Dog CT. We'll continue this. I was worried this slide deck was getting too big and it was going to crash. So I thought I'd better break this into a separate slide deck. So we'll show you the, should say Black Dog CTG, I think it says. Yep, okay. So this is the, the next portion of the project was moving in that combustion turbine and combustion generator. The operating floor was elevated. They cut a hole in the building for us. We're going to lift it up, slide it in. That was the rigging on the generator. Again, some of the engineering that we have to do. Wire rope on the top portion. I think those are 2.5s, 2.5 inch, 2.5 inch by 30 foot, and basket up over the crane, the hook crane. And then we had synthetics on the bottom. We had ENR 13s on the bottom, big spreader bars. Again, we're doing all this virtually in 3D CAD ahead of time. And I'll go ahead and play this one. Here's a time lapse of the combustion turbine coming in through that opening on the outside. Slide in on our slide track system. Our biggest issue when we do this type of work is where are those loads going to go to in the plant? A lot of times we can, like the gantry track is over the power block of the turbine, so there's good support there. But coming in over that mezzanine, even though that mezzanine previously had a 300,000-pound transformer on it, we still had to do a lot of creative load shifting and sharing among different support elements to get the load to go where we need it to go. You can see gantry's picking up, again using a wire rope there. And in this case, we had to pick it up off the slide track. It's over the generator foundation right now. We're going to move it forward, and we actually had to move it beyond the foundation. Again, one of the advantages of being on a T&M basis is they figured out there's some intake ductwork that had to go in kind of underneath this thing, and they figured out it'd be a whole lot easier to do it before this turbine is set. So we moved the turbine forward, but we couldn't move the turbine forward with the ducting in place, so it was kind of an iterative process. So we moved the turbine forward. They lowered this goofy-shaped intake duct, which at one point they thought they could get in place after the turbine was set, and wiser heads prevailed. They said, you know, it's just better if we put that in during this process. So we worked with that contractor to get that in place. They're maneuvering that. Well, we're suspended right now up in the air. We move back over the foundation, coming back down, and we're clear of that. So we're back down, get the gantries out of the way. So that was a one long day worth of work there, sped up, so you can see what's going on. All right, we go to the next slide. This is another video. Here's the generator coming out of storage on our Goldhofer, backing down to the crane. We're going to get the rigging on it. This is our CC 2500, 550-ton crane. It's got the super lift wagon on the back. We're going to lift it up onto that external mezzanine, onto our slide track. Then we're going to slide it in through that opening again. So gantries are coming up, so we can slide underneath the gantries. And again, this is a full shift worth of work to do this work. We had a couple days between this and the turbine set. They want to do some rest of that duct work and some leveling and all that sort of stuff before we brought this one in. And then get it up. We ended up blocking it up so they could do some grouting. Then you see our slide track system moving back out. Outside crane's going to start taking that. Now we start knocking down our track. Okay, next one. So this is another video. So if you're not familiar with slide track, slide track sits on a kind of a big fabricated beam, and it's designed for moving big, heavy things. It's really, really handy. So we've got a pair of hydraulic cylinders on each track, pushing. Basically, we'll call it a slide shoe that big I-beam is sitting on. That's got a Teflon pad underneath it, riding on top of that track. We usually lubricate it with just plain soap. And so the hydraulic rams are stroking out. This is that 500,000-pound generator. Well, this is the turbine, I think, actually. And then once the rams stroke out, they start retracting. We've got a cam lock on that back shoe that locks in to those notches on the track. They're kind of spring-loaded. so they're kind of like a big cog. We can run them either direction. We could push or we could pull with it. So we push out the stroke of those cylinders. I think they're about 24 inches. We back it back in till the cogs click in, and then he'll call on the radio that they're in, and they'll reverse the pumps, and we'll just start going the other direction. We just keep creeping along. It's real nice, easy, safe, controlled way of moving really, really big loads versus, say, using some rollers. So another slide. Oh, next slide. All right, there's a combustion turbine going up for the pick. Again, a lot of good wire rope in there, not only on the crane, but in the rigging. Up onto the mezzanine. Up on the slide track. That was on the mezzanine. You can see we got a variety of beams and stands underneath there, on top of grillages, on top of their deck. That was an iterative process with the Excel structural engineers. Where are we going to take this load to? Because even though there was a 300,000 pound transformer on top of there, we're moving 400, 500,000 pounds, and it was on top of pilings, and they weren't really sure what it was rated for or what it was good for, so we had to be creative of how we shifted those loads. Inside, again, close-up of setting it down. Come up with a foundation. One of the things we had to do on the outside, we had this low pair of power lines coming off the other unit in there, so there's a coordinated effort. If these, they knew a day ahead of time if this unit that fed these power lines was going to be on or not. If they weren't, because we had some clearance issues, we had to isolate them, take them out, all that sort of stuff. We had to put that steel plate down so we could get around them a little bit. That was a tight clearance area there. More close-up of some rigging. Slide track again. Originally, our first proposed plan to get this thing up there, Vice using one of our big crawler cranes, was we were going to extend our track system beyond the mezzanine onto some big shoring towers, and we were going to have a pair of hydraulic cranes pick that up, so we could basically pick it up at a short radius with the hydro cranes, move the slide track out, set it right back down, pick it up between those towers. Goldhofer would come in between the towers, pick it up, move the slide track out, set it back down. And this was our original proposal going into this. The original move was going to happen in the January time frame, and one of the things you can count on in January, Minnesota, usually, is that it's going to be cold. So cold that we'd have enough frost in the ground that we wouldn't have to put footings in for these towers, because the geotechnical guy says, that'll be like concrete. You'll get 4,000 PSF out of that easy. No problem. We put the towers right on the ground, bare parking lot, a couple feet of frost, no issue. Project slipped to February. It was a warm February. Frost started to come out of the ground. We had to shift plans and go to the big crawler. So that's where we planned, and that's where we ended up. So I think I've used up a good portion of my hour here. We appreciate the invite, and I hope you enjoyed seeing some of the projects that your products and your services are used on. So thank you very much.
We have time for questions.
I'd love to entertain questions. Absolutely.
Questions. Oh, right here. Stephen?
I was just curious if you knew some of the particulars of the details on what caused the recovery of that piece that was outside of the city here.
Yeah. From what, again, we didn't do the accident investigation. And talking with the contractor, we not really a competitor of ours. I mean, we're in the same industry. They're in state doing their work, Project Cargo, so they weren't really competing against us. But our understanding that what they told us is they were trying a new friction material. So whenever we put loads, I should have showed it on some of the close-up things there. We always put a piece plywood or something steel on steel. We never go steel on steel on anything we're moving. Steel on steel has actually got a pretty low coefficient and get away from you. So they said they were trying a new product, friction product, between that vessel and the trailer, and apparently it didn't have enough friction. It was compounded by the fact that they were cruising down the road, and I talked to the driver, and he was still, understandably, hours later, still pretty amped up. He was still pretty shaky, and he should be, because honestly he's lucky to be alive. So they're cruising down the road. When you move ahead, this is an oversized load, high load, so we always run a truck ahead of it with a height pole, just to make sure the lines were not going to catch anything. And what happened was that truck called out a low line, or what they thought was going to be a low line. One of the advantages, disadvantages of those modular platform trailers, that trailer, if I remember right, had 109 tires, probably 110, over 100 tires on that trailer, all of them with brakes. So you got that big load, you actually got quite a bit of braking power. I mean, incredible amount of braking power in those trailers. So that trailer stopped, tank didn't. A lot of broken rigging, a lot of broken chains laying all around that site. So that's my hypothesis.
Do you know how fast they were going? Because I know.
Officially? Officially? They said 35 miles an hour. Okay. Yeah. Well, we'll stick with that story.
All right. And it would appear. So I was.
You want to go back to those pictures? Can you bring that? Bring that trailer pictures back up?
I know there are various tie-down requirements where I'd previously worked for barge transport, over ocean transport, coastal transport, road transport. Yep. And with these self-propelled or the dual-lane multi-axle trailers, this is getting into a segue of requirements, ASME standards for these trailers, because in the United States there really isn't much out there, from my understanding.
Well, there is and there isn't, right? I mean, this is clearly a commercial move that falls under FMCA, Federal Motor Carrier Act, and DOT criteria. DOT's got very clear criteria for securing loads. I don't remember what it is off the top of my head, but I think it's 1.5 or 2 times the load. I mean, this is a DOT move. It's on the highway. It's a commercial carrier. Did they meet that? When you look at the challenge, and it's a good discussion point. The challenge we run into with these jumbo and these super loads is you look at the rig points on the trailer, and a lot of times there's just not enough points you can get resistance out of on the trailer. That goes to securing anything anywhere you can, along with that friction material between them. Any other questions? Why we did something? All right. I'll be around for a little bit afterwards. You got any questions? I put our lift and haul guide out on a few of the tables. If you want to get some more information on our company, there's a few of those laying around. But we appreciate the invite and enjoyed talking with you.
Thank you very much. Great presentation. Very, very good. Very good.